Hey guys, I'm Sam with Scrappy Industries. Welcome back to our 50-ton Talbert trailer rebuild. This trailer is a 1995. I'm a 1992 model, but we've seen a fair bit of corrosion over the last 30 years on this trailer. As you saw last time, we chopped all this stuff off and we're getting ready to go back together. In preparation for that, I still need to do a lot of grinding, arc gouging, all that to get everything kind of smoothed out, ready for reassembly. It's loud, it's dirty. Let's get back to it. So I've been gouging away at this and I'm picking up a few things I thought I would share. If you guys are also learning to arc gouge the way I have been, definitely doing more than I ever have on this project. It's a super useful thing. I think if you're doing any of this sort of work, you should know how to do it. So one of the biggest things I've noticed here is when you start and you want to grab the rod probably halfway or so, and you turn the air on with this slider, you need a lot more air when it's this long compared to when it's here. And what you'll find is things will be going well. It'll maintain the arc and you can blow the molten metal out of the way. So as you keep going and the electrode gets shorter and shorter and you're closer to that air blowing out, you can't maintain the arc. It just like, just keeps going out. But you gotta back off the air the closer you get until you reset, because you've burned up some of the electrode, and you reset, and then you need more air again. So that's the biggest thing I've noticed is your air control. There's a lot to that, because if you have not enough air, the metal's not blowing out of the way, it just sort of pulls up there, puddles up there. So using the appropriate amount of air seems to be very important. I'm running 3/16 rod. This is a 250 amp machine and I'm running it wound out. I know it's not the best thing for it. It's an old welder. If it explodes, it explodes, unfortunately, but it's been doing a pretty good job with it. But yeah, 3/16, 250 amps, DC electrode positive is what we're running here. If you run electrode negative, I think it is less amps you need potentially. It said on the pack. But that's what we're learning. I did take off the one airbag mount. I think we're gonna take them all off because it's really easy, because they're just kind of like stitch welded on, so they're easy to buzz off. Cleaning up our suspension hangers, and as well as the upper side of the bolster, because it's easy to get to from this side. I think we're probably going to need this thing flipped back over again to kind of finish buffing all that out. Anywhere like here, I got a little bit too deep by accident into the flange. We'll fill that up with weld, buff that off. I did get some special dual shield, like 100 KSI high strength wire. That's more for the frame repair on the deck section. Here, we're just gonna be welding mild steel to the 514 T1 and the regular 514 in the web. So I don't think we're really gonna cause any issue whether we ran just regular ER70 hard wire that we normally run in the MIG welder. I think that would be fine for this purpose. However, getting down in and repairing the flanges, I wanna put the high strength in so that it has the same properties as what we destroyed, more or less. That being said, we're gonna buzz this guy off because we're gonna put a C-channel across here for our whole airlift. We gotta do a lot of drawing in SolidWorks to get all this drawn up, figure out the airlift, and get the brackets burned out for make all that hinge. So we got our work cut out here yet. I'm gonna keep air arcing, and then we'll come back in with a grinder from this point. I'm basically just trying to save grinding by air arcing off as much as I possibly can in all this. That way we're not grinding for 15 years. That side wasn't on too long, I guess. See all the scale over there? That's what I'm trying to fix. There's so much scale on these ones, you can't tell what's steel and what's scale. They're also welded underneath, which I think I got it all.
Guess we need more burning all the way around. Don't leave your square hanging out beside where you're arc gouging, because you may or may not destroy it.
So when this trailer was built, Talbert originally had a piece of C-channel going across right here. And the problem was, with a big excavator, you need all this clearance that you can get for a weld. So when the excavator stick and mainly the curl cylinder for the bucket, they could sit down in here. So previous owner cut this all out, welded this in, but it's not very square. And in my opinion, it just doesn't look good. We got a lot of extra weld from the original C-channel kind of hanging out down in there. So I want to start over. We're going to cut this out and make a new piece for that, because I just think we can do it to make it look a little more professional. This is just something that bothered me kind of from the get-go at looking at this trailer. So the shocks were stuck in it. We're replacing them anyway as well, so I'm not even going to worry about it. We'll reach down in here with a torch and chop her out of the way.
Boy, we can turn this over. Well, my back's had about enough of working on the floor here, so I'm hoping that now that everything's out of the way, we can come in with a 5,000-pound lift, scoop it up from the side, and use it like sawhorses. So let's see if it will pick it. I feel like it will. It's my boat. It will. Oh, like nothing. I honestly don't know if we need to remake these or if we'll just gouge them out, because there's not much stopping us from taking those off. I don't know how many times we've swept the floor on this mission so far, but it's quite a few. Just every pound of scale and slag and everything else we've taken off this poor old trailer. All right, now we got our area cleaned up a little bit. Let's get back to work. We got some more grinding, gouging, take the bushings out of these, I guess, see how that goes, and then we won't have to make those new, which is, as I'm saying that, I didn't check the diameter because I assumed I was making them, so the slots in my hangers probably don't match that at all. Never mind. So I'm going to take the needle scaler, try to clean up everything we can, and then we're going to go back at it with the air arc and the grinder. Basically, we just got to prep up all of these cut-off areas, get them ready to weld the new parts on. So the big reason I want to get a lot of this scale off is the sandblaster really struggles with that thick scale like that. And you can see the needle scaler didn't even want to take some of that off. So I go to the air chisel as like the super duty
needle scaler, and then I'll come back in with the needle scaler once you get the bulk of that off. That seems to be the most effective way. If you try to take that all off with the sandblaster, it is so hard. I'm not saying you can't do it, but you'll just be sitting there just burning through sand forever. So I always try to get that heavy scale off mechanically before blasting.
That hurt. Ow. A piece of molten metal went down in my boot. I don't understand. Oh, it must have burned. So it burned through my jeans to get inside my boot. Oh, that hurt. This is fun. This is a good time. I don't know that's going to stay very well, but it'll get us here for a little while. Look at my sock. It's got holes all burnt in it. Whew, that was fun. I don't know what we need down here for FR pants or what, but man, I want to prevent that from happening again because that was terrible. I did not feel good, but these things happen. I think part of the problem with standing in here is all this hot stuff is running down the flange and off, you know, kind of down there. I think if I work standing from this side, it would be safer, kind of just staying back this way and blowing everything in there. Man, that hurts. That still hurts a lot.
Back at her.
Well, that pretty much wraps up what I'm gonna do on this thing. I got a guy starting tomorrow morning, and he's gonna be our main kind of welder going forward on this project. Obviously gonna help him out, do a lot of the tacking, get everything sorted where it needs to be. Hopefully he works out. I think he's got the ability, but if not, I guess then we'll be back to us doing it. But I'm gonna haul this into work along with the deck, and I'm gonna let him do a lot of that kind of stuff. We're gonna focus on a lot of the side little things for this, like the bushings, making the bolsters, getting all that stuff ready to roll. I just wanna keep this project moving forward as quickly as we can. Unfortunately, I can't devote all 100% of the time to everything I'm trying to do with this. So this is the first kind of contracted out work by Scrappy Industries here, but as things are growing and more of you guys are watching videos, kind of make more things like this possible. So we got to kind of amp things up and keep the projects rolling along. So I'm pretty much going to clean this off. We're going to take it outside. I want to strip the wooden deck off of the deck insert before we haul that in, and we'll just throw it all in the black trailer, haul it into work. Can we wind this through the door? We sure can. Got it. I'm just taking that in so we know how to weld the pads on the new axles. So now that we got the back end all apart, hauled it in here to work, now we're gonna get to work on assembling the rear bolster assembly. Now I wanna show you a little bit of the design process on this and what I used to create this bolster. Now the original Talbert bolsters, they had this nice radius corner to them. I measured it with a tape measure and I came up with it. It was about a 1-inch internal radius here. On the original design, I actually drew this in multiple pieces
and I was just going to weld that corner up. You can see what that looks like here. So I was just going to leave basically the top and the side, and we'll weld that outside fillet weld. Well, I just really didn't think that would look that professional, and I came up with a way that we could make that 2-inch diameter, 1-inch radius punch in order to make this. So I'll show you that out in the shop once we get out there. So after thinking about it a little more and basically how we could do it otherwise, I drew this part here where the top and the outside are all one piece and the bottom is all one piece. Now this is exactly how Talbert made it. They just didn't have holes in it, and their top and outside piece was 1/4-inch steel as well as the bottom. I did the bottom out of 1/4-inch steel, but the top and outside are 3/8. We also have 3/8 internal supports here. And the reason I did that was for the chain hooks. I think 3/8 is going to hold up a lot better over time to those chain hooks grabbing them, as well as if you would dip a chain down through here, through that center hole and back up. I think 1/4 it could actually damage that. So I think 3/8 is the way to go on those center supports as well. So this is what the final product looked like. I drew the I-beam, and these are 1-inch thick flanges, but I actually put a little bit more meat to them just to give us some tolerance so we can weld up a gap here. So the way that SolidWorks handles sheet metal parts is you can work either from a flat pattern and add flanges and bends and that kind of thing, or you can start with a solid and tell it, hey, I want this and this to be a bend and this part to be the original part, and get rid of these sides, things like that. So I typically will work from a solid body. Features like this are what kind of set SolidWorks apart from Fusion 360. Inventor is more Autodesk's direct competition with SolidWorks. I used it a little bit back in high school, but since then haven't used it much. I don't have anything against it. Just kind of grew up in SolidWorks land and been with it ever since. Fusion 360 is not a bad software. If you want something, you know, cheaper at home, it just doesn't have the capability of Inventor or SolidWorks or Creo if you're in that space in the real industrial land, like what John Deere and Caterpillar and those big guys run. To create a part like this, if we're looking at the bolster bottom here, I'll jump back into where that's edited. The way I started with this is I just created this big trapezoid box. And I just measured what the old ones were. We set the top width, we set the bottom width, and I extruded it out basically to match what that old one was doing. So you can see I ended up setting the bottom to 7 inches. I set this to 65-degree angle, and then I extruded it out. So that created basically just that solid box. So from that solid box, I use a feature called a cavity. And a cavity allows you to take this other part, which is the I-beam I already drew, and I just drew it with these fillets in there for the weld. That gave us clearance for the welds that are already on that main rail. And then by using a cavity, we can basically, I had extruded through that beam. The cavity just says, oh, the beam's here, we'll cut your part out of the way anywhere that that beam is. So that's kind of an automatic way of coping it through that I-beam. So once we have that done, then we convert to sheet metal because we already have our solid part here. So when we convert to sheet metal, all we have to do is pick the bottom face here, or a side face, I think is what I picked. I picked the side face and told it, hey, this is the sheet metal part. And then you select the bends and you come down and you say, hey, this corner's a bend, this corner's a bend, and I'm going to tell you that I'm going to run a 0.125 radius punch when I'm in the press brake. So it knows how big to make that internal radius. And then from that point, it takes your solid and says, oh, here's your sheet metal part. And the power of having that sheet metal part is now when we open just that bottom of the bolster, and you can actually go to sheet metal here and flatten it. So that takes those bends and just gets rid of them. And now we say, hey, this is what we need to send off to our metal guys to cut this for us on a CNC plasma cutter. So once I switched to using the top piece, we did it the same way. I started with that top solid, added the flange on the outside. But then we can come in and put the 1-inch fillet on this lower part that matches the radius that we're going to bend on the upper part. And before we make anything, we can already visualize how this is all going to work out so that we don't have to sit there with the grinder and manually put that radius on there. Now, to make that 1-inch radius on the end of that top piece, we're going to make our own tooling. The reason for doing this is we only need to make 4 bends. To buy press brake tooling is extremely expensive, and that's because it comes in tool steel, it's very precision ground, hardened, it'll last forever. We don't need that. We need to make just a couple bends. So what I'm going to do is buy 2-inch diameter round bar
and a little bit of 1/2-inch flat bar, and we're going to weld that on top. Sal's press is a Cincinnati, which uses American style tooling. It just takes that 1/2-inch tang, can be clamped in the top. The bottom should have a tang, and I think that's what he's able to get off of his friend to use a 3-inch open bottom die, and it'll clip in the bottom and use our homemade on top, and we'll have to figure it out from there. So now that I showed you how we designed the bolster, let's go down, make some tooling to make the bolsters, and we also need to do the fab work on the little hanger brackets for the suspension as well. So this is going to be our 1-inch radius press brake tool. This is a 2-inch diameter bar to give us that 1-inch radius. So I'm holding it up with 3/4-inch parallels. That should put us right in the middle of center line here. And that'll allow us to go ahead and put some little welds on there and hold this in place. I'm not going to weld it super solid because it may or may not be permanent. Now I just surfaced the end of the bar. Now all we need to do is put chamfer on it. Now this is cheating, but now that we got this tool room lathe, it sure does spoil you and make life easy. I love these tool room lathes. All right, put this clamp on there just to kind of hold everything good and snug. I'm going to start by tacking the ends, and then I want to weld kind of opposite, you know, some up here and some down here, just so it can't pull from one side or the other on us. Alrighty, that is our custom tooling. We got all our steel in now. Let's check it out. So these are the brackets that are going to go inside the bolsters. Those are 3/8 thick. I ordered these for the shop press. 2-inch thick steel. Those will be nice to have. We have our 1.5-inch die we're going to need to use. Sal primarily does real thin sheet metal, so he doesn't have anything even this big. We're going to need that for the 1/4-inch tight radius bends on these. So what I'm going to work on tonight are bending our suspension components to make our new suspension hangers. These are the sides. That guy there is the back. That's our little gusset that we torched off for the shock mount. Then these are the 6 new airbag plates I got. As you can see, they're looking a little happier. So this has nothing to do with Scrappy Industries, but we're running these calibration tubes, so I figured I'll let the lathe run while I'm here on this Friday night. So this is a dual spindle lathe, and you've seen this in a couple of our videos, but not running to this extent. You can see it parts off most all the way through this part, and these are PVC plastic. And then the sub spindle comes in here. They time up their speed. It's closing the jaws now on the part. Now it takes the part over here and works on the back side of it. It's facing it. Boring the taper for the pipe thread. And that's threading it. And it'll come over here. And it spits it out. Then it comes back over here and it feeds the bar. And does it all over again. Until it gets mad. Because the bar feeder's out of position. Why? So these are the bend drawings. We're going to put an 1.25-inch flange, and that's going right here. 4 of them are going to get bent like this drawing. The other 4 will just flip them over and bend a mirror image. This piece here is the back, which just gets this 35-degree kick in it. Set that up.
And then that's our final assembly. I was going to try to locate that back one with the kick in the hanger. And the width of the backer piece, this piece, is the same as this. So we have that nice open fillet weld to make there on those two corners. Now people did mention bending the center, basically open this up so we could get the press brake down inside there. Or just draw the part so it would have came up here with 3 bends. That would have probably been our best bet. And then you make that center bend last. That's probably how we should have done it. I had already ordered the steel when people made those suggestions. This is our little 35-ton Amada press brake. It's perfect for these kind of parts, but it's not big enough for the bolsters. So we're going to go to our friend Sal's shop, hopefully tomorrow, and bend the bolsters. But for tonight, I want to get started on these spring hangers. We can bend that flange, bend that kicker, start tacking these guys up. Turn the power switch on. And we have our power button here. And the hydraulic pump gets kicked on with that. And we need a bottom die because I stole it. So this little chunk of 1.5 will work just proper for us. 1.5 is right at the 6 times 1/4 inch, which is what I like to go by for rule of thumb. All right, so to home this thing, you put it in manual like that, and we bring her up until it touches. And it's going to stop short because we were using smaller punches and dies earlier today in it. So we crank this and that manually adjusts the depth. And we bring it up till it just about touches. Then we keep an eye on this pressure gauge down here. And we need it to just hit that little red line there, you'll see right there. And we come up and hit origin, and that homes it. Let it back down. I manually crank this back off so if it jumps out of a program, you don't have a big issue. Turn that off, and then this button here, it'll home the back gauge. So now the back gauge is homed, it knows where it is, and we're ready to program that little flange. So we'll jump into memory. We'll do this on step 71 I've been using for random jobs. So basically we tell it here, we know we're at 1.25 flange, 90-degree angle. Our bend width on that, that's essentially the length of the bend, which I did not put on the drawing, and I should have. But it is about 11 inches. This tells it kind of how much to overcompensate for. For that 11 inches, start with a 0, extra helper. And then for carbon steel, we like to use 32 for our tensile strength. I think it's 32,000. Thickness 0.25, opening at 1.5, punch radius is 0.120, die radius doesn't really matter, die angle is 85, I think that's right, yes. Alrighty, input that, and then try to start that program, except for we are like running over the die. Alright, so to bend it like this drawing, we're going to put it in there this way. I'm going to make 4 of them that way. Now, like I said, it doesn't matter. We need 4 of them one way and 4 of them the other. So we'll just let that hit. And that's our flange. Let's check it with the square. I think we're pretty much right on the money on 90. Take it. All right, 1 down, 7 to go. Let's get them bent up. All right, so 4 holes to the left, 4 holes to the right. And I'm just hitting the pedal here with my foot. you can watch the pressure gauge, see what kind of tonnage we're doing. And there's our stack of parts. So that guy sits on that side. And that guy sits on that side. Starting to look like we have some hangers. Bend those little guys now. You can see, I don't think that's enough. More. So then you can just kind of creep up on it. Take 20 thousandths off. Yeah, that's good enough for me. So you can see basically the air in our first one. You can press that out though. That's the one we straightened. Like we never even messed up. It's not if you make mistakes, it's how well can you hide them. So I'm just trying to figure out how this all lines up. Brake mark's a good indicator of parallel there, but I want to take this mill scale off before we weld. This measures right about that 4 1/4 that we were looking for. We had 4.27 going down there, and we're right about at 4 1/4, so that works out. And then that 1.5 inches from center back, again, kind of approximate. That seems to line up. When we go to put this on, we're going to have to be able to stand it all up, I think, so that we can square it. I'm just cutting off that little bit of that edge from bending. You get that little bit of distortion. And I want to make sure we're sitting flat to help hold this square, because that is the right width. A representative square. We're going to scoop up our parts here that need to be blasted. Go give them a quick little dusting. We don't shake them all off first. So I started trying to weld these, and I'm fighting the mill scale, and basically I'm like, this is dumb. I want to blast them to prime them and paint them anyway, so let's get that done first. And there's all our parts all blasted up. We're ready to assemble. So we brought our parts and our prints down to Sal's shop, and we're going to try to bend some stuff up. So we're not sure if this 1/2 inch tang will hurt the press or not. I guess it's a matter of where is it designed to take the load. It is just one solid bar there. Because like it's just hitting on that thing. Right. I don't think it would hurt it.
All right.
But it's your press.
I know. We could try it.
What is this, 100 ton?
175 ton.
175 ton. Oh, I didn't realize it was so big.
Yeah, that's a BX 175.
And you guys are always working on the thin stuff.
Yes. Yes.
So we have our 1.5 inch bottom die here for the 1/4 inch, which is the bottom of the bolster here. This is the flat pattern. We're gonna make a bend here and here for this, and they're each 10.385 is where the backstop will be set. See, American tooling has that tang on the bottom die where European tooling doesn't, which is what our bottom die is because it supports it by the outside. You just kind of set it on there and center it up then?
And hope that it doesn't move.
I guess it finds center, huh?
It will when you put the top die in, and then when we're bending, we just got to make sure we don't
touch it.
Yep.
So that crank allows you to control the crowning, which is kind of like the arch to it. Because if you have a real long piece in, as the press actually flexes up, that makes up for it. Are you on the gooseneck for everything?
Well,
Is that all you have?
what did you want to use for this?
Oh, I just figured it would work. I think it will work straight, but I'm not 100% sure on that.
Yeah, this you really got to pay attention that you don't take it up without tightening it, because this will fall right out.
You just like kind of push it tight then when you do this stuff?
I'll take it, yeah. So what I'll do is, I got like about an 1/8 inch gap right there, and just snug them up, and then bring it down with the palm controls and set up, then that'll tighten it. That look pretty centered in there?
I think so.
Okay. So here's what we're gonna do now, Sam, because we have no idea where we're at. But we're gonna get a speed change roughly right there. Right now we're transferring from the ram where we're at right now for our speed change, where it comes down and stops
Okay.
before it. And then we'll come down even further to where we think we're gonna be roughly.
So you don't bottom out, like the Amada, you set 0, you run it to the bottom, and
Okay.
it does all the math back from that.
Oh, does it?
Yeah.
Okay. No, this one here, it's kind of set. You know what I mean?
Okay.
Yeah, it doesn't go to a 0.
Okay.
You know. So what we got to figure out roughly is if we had. Do you have any tests, any 1/4 inch we can test bend at this angle? No. Okay.
I think we just sneak up on it's probably our.
Okay.
Can you set like
I can
the
set the gauge.
backstop
Yes,
then
yes,
to that
I can
10?
do that.
Yeah.
I'm gonna bring it into about 2 inches, or where it's at right now, just so I can see roughly the height.
Okay.
I'll have to adjust it a little bit, maybe. Yeah.
Yeah, we got to raise it down.
Yep.
You just crank this hand wheel then.
Yep. Should go counterclockwise, Sam. I went 5. What did you go?
I think 5 or 6.
Go 6. Yeah. 6 will get us just below it enough. Okay.
You're setting the 10.385 for the backstop now. And that's just based on our drawing here.
I'm just gonna run it through. Always run it through when you're not kind of sure where you're at.
So this piece of stainless is going to be like a test run to find where we are in the world.
Okay. We know we probably got to go more. What angle is that, Sam? Do you
65 degrees.
Okay.
But I guess stainless has a little more spring back too, huh?
That, and it's hard, so we got to go. We know we got to go a lot more.
Yeah.
It's just a guessing game until we get. What did you say you're actually doing with your low boy again?
I'm like totally rebuilding it.
You are. Okay.
Suspension.
That's all right. It's shown. It's just a hair over what we would say, and then with the length of that right there, it should be close. You know, should get us real close.
As long as the steel from stainless doesn't bite us.
Right.
Yeah.
So you want to grab one end, I'll grab the other.
And we can not touch the die.
Yeah. Right. We don't want to slide the die. Here we go. It's got a little bit of a bow to it, but here we go. Okay, now let's just stand it up in the air. You got that?
Yep.
So
You know what? We also have that part I brought in to
Okay.
check it.
We can do that. We got to go more. So let's just set it right here and let me bring it down more.
This guy's our internal support. So that's, as good a gauge as any really on where we need to be.
wonder. And now the key is us trying to hit it in the same exact spot. What do you look like, Sam?
I think we're good.
Okay, here we go.
I don't know if that was enough.
It's okay, we're just gonna go 10 more. You like? Yeah. Here we go. She bumped. I know she went. Question is, did we hopefully not go too far?
Oh man, that's about money right there. Maybe it's the fuzz too much. It's not far off.
Right.
Yeah, that's not as good as you could ask for, really.
Yep.
It's like this side seems like it's a fuzz less.
Well, we can.
I mean, I don't know how you can complain about
I don't
that.
think for
Yeah.
heavy fab work, that's pretty good. There's a chance that since we hit it, this may come out to be a little bit under,
Right.
possibly.
I'm glad I see the same thing. Moment of truth. Oh, buddy.
I don't think I'd complain about that one bit.
Perfect. That's just that little tip right
Yeah.
there where they burn it out.
Yep, that's pretty good.
That's perfect.
All right. Now that we did that, we know these.
The golden trailers now.
If we get the tooling, we can do that. Good, or you got to come my way. Okay, here we go. It still hit, but
Want to check it, or are we going to call her good now?
it's yours. If you want to check it, I'm more willing to. I tell you what, Sam,
I think
that
we're
is
ready to
great.
roll.
Yeah, let's roll.
I see why those big presses have those arms
Yep.
stick out of the front.
To make it a little bit easier on guys bending. Got it?
Yeah.
I bent up pretty nice. I'm impressed.
Yeah, that was nice.
It stayed nice and consistent. Yep, just be careful. You won't drop on your finger. That one will go right here, Sam. Wheel it right around here, man.
So the 3-inch bottom die here, borrowed from another friend, from Sal's friend. It is no joke at all.
Nope. Yep. We can go up a couple more, Sam. Go up like 3 more. Okay.
This is our custom 2-inch diameter. This cold rolled steel is all it is, nothing fancy. And then a 3-inch bottom die. Really, the tonnage on this isn't crazy because it's so short of a bend too.
And you got a big opening.
Yeah. Still, that's somewhere there. Or should we hold a square to it?
We could still do that.
I feel like we're pretty good.
I feel like we're pretty good. Let me see here. You ready?
Well, we didn't overbend it. That's the good news.
That's the good news. The bad news is we don't have that crisp point from our other die to try and hit, when we go to hit it again. It's going to be a little bit of a guessing game to get that to go in the same spot. That's
I still think it's so big, it's probably going to go there.
yeah. Okay. Let's pull it out for a second and see how much we're thinking we're under.
Not too bad, really.
No, not for a first shot.
terrible. Not 90 yet, obviously. So you're just basically increasing by thousandths of an inch how far down
Yes.
we go.
Yep.
What's your guesstimate on that much?
With this here, probably at least like 25 thousandths maybe. So we'll go to like 12.2, because right now we're at 12.223. So if we go to 12.2, and it's just a guess, that's like 23 thousandths that we brought it down.
Right.
Just to see.
See how much that changes it. I feel like this is probably way less sensitive on this big tooling.
Yeah. It very well could be. Okay. And a lot of it's going to have to do with how we hit it. If we hit it in the same spot, okay? I'm going to let you, since I'm working this pen, I'm going to let you eyeball it, Sam, and you tell me
Pick it up.
if I got to go up, down, or whatever I got to do.
A little more. Yeah, that's pretty close.
Okay, here we go.
I don't think we hardly moved it.
Yeah. We're with the bigger bottom like this.
I bet that 25 thousandths isn't much.
No. We're going to come down. We're going to come down about 100 thousandths.
That big radius looks nice though.
That is real nice. Keep that, baby.
Yeah. Oh, it'll stay right here. I don't have anything closer.
Yeah.
So I'm trying to judge. Pick it up a little bit. Yep. Can we pick it up a little more? Yeah, that's good.
Go with it.
You're good. Yep. I'm trying to put it back where it was. Yeah. Still needs more of it. It's
Okay.
close though.
Okay. All right.
Higher. Yep.
You like?
Yep.
Here we go.
Touch more. Yeah, that's good. That was close.
Okay. So we're over 90 a little bit from what we want to be.
Not too bad.
No.
Should have gone 40.
Should have got 40. I'm going to take it up 10 more. Was this cut with a water jet? Or you took a plasma?
I think it might be an HD plasma.
I'll tell you what, man, that's clean.
They do nice strong.
Okay, so let's. What I usually like to do is like hit one side, and then just when it comes in, just touches, then.
Rocket in.
Yeah. Ready? Let's see what we got.
Oh man,
That there is
right there.
right on the nuts, man. That's good.
This is the actual installed hoon. Oh man, like we designed it like that. That's a jet.
That is. That inside radius turned out really, really good.
Yeah. So I wanted it open because then you can hook your chains and stuff like
Right.
tying down on the back.
Yeah.
And then that's why I made those inside 3/8 because I thought if you wrap the chain, it's going to go through that hole.
And come back up.
And I don't
through
want to be able to like bend that.
it. Yeah, if it was quarter inch, it'd definitely bend out.
Yeah. And then you can just take your 3/8
That's
binder
where it would really,
right there.
yeah, work good right there.
So this will fit over the top of the flange of the frame. That should be an inch. A little more than an inch. Yep, we got a little clearance over an inch. It's an inch thick flange on the main rail. That's awesome. I'm excited about these things.
Yeah, those look nice, man. And just bump it.
So we overbent this guy just a fuzz, so we're gonna put it in upside down and essentially unbend it.
You're gonna be able to tell me how much you want me to back break it.
All right,
Sam,
let's
I'll
see
tell you
that.
what,
Yeah.
Hit that yellow button. That's the ram up. And I'll check it while it's here. Yep. Maybe I won't be able to. Oh man, Sam.
Oh, we're on the money.
Yep. Pretty good.
We can get lucky.
We can get lucky every now and then. Okay.
Yeah, this guy sits down inside. You'll see here when we weld it up, but it'll be inside under here and here. Well, Well, I'm happy with that. Doesn't even look homemade.
It does not. Yeah, that looks really good.
The old parking block.
Yep.
Well, this press is nice. Well, you guys bought this new, what was that, 6 or 7 years ago now, probably?
New in 2016.
Yeah, not that long ago.
Yeah.
Time goes too fast.
Yes, it does.
So these guys have this little fiber laser, and they do mostly all thinner stainless work on like commercial kitchens. Super nice stainless work. So this is a little out of their realm. That's why we were borrowing tooling and coming up with ways to make this happen. So I sure appreciate your help, Sal.
Anytime.
So we got these all bent up last night. Let's get to welding. Since I was struggling to hold everything square and hold the spacing, I had this idea: if we take a piece of pipe, put a bolt through here, and hold both sides together with that bolt, I think that'll help square everything up while we tack these. So I just cut this on the saw a hair over 5 3/4. We're gonna take it on the lathe and take it right to 5. I think I'm gonna add like 20 thousandths. So, you know, something like 5.77. That'll give us just that little bit of clearance for us to put this together, and then it'll pull it in tight. So this lathe is pretty cool. You can actually run it as a manual lathe if you do it like that. Now you can just override both of these. But obviously you can always take back over control, and it still kind of works like a digital readout of watching where you're at. I'll true up one side. Alrighty, and we're about 15 thousandths over, which I think is pretty well perfect. 18,000, somewhere in there. So if we take our pipe, and I have a bolt here, go through this, and now that's holding that spacing. Alright, so I'm just kind of clamping that there. We got our 90-degree magnet. We got a spacer pipe. This is just sitting here to check that with, because that's what we're going to be able to weld up. I like that a lot. The spacer pipe is key. Let's get her tacked. Right. So to me, the most important thing is we're sitting square there, because that's where it's going to get welded down to the frame of the trailer. Check around, that looks good. Let's see how that wouldn't be, but well, that's off a little bit. Really doesn't matter. I think we're within tolerance is what we're going to call that part. That's making it square this way. And we'll kind of try to hold that there with the magnets. Now, so we're bumped up into the bar and we're square off of this edge of the table. There. Now, see how there's that slight gap? We'll loosen that bolt and we'll pull this into the bar on this side now. Is that Shaverson? They're all tacked up. Let's weld them out.
Getting ready to weld up a bolster now. We're going to start by welding in the 2 baffle plates, internal supports, whatever you want to call them. I want to weld these in. Then we're going to stop and we're going to primer all the inside of this with zinc primer as well as the bottom at the top. And I did want to put a little bit of care in. You remember we were looking at the hooks in the drawings. These are kind of the model of 1/2 inch grab hooks. So 2.75 inches gives enough clearance for the hook to hook on that hole and not have the tip bottom out into this. So I wasn't just kind of willy-nilly shotgunning these in. We are going to maintain that 2.75 back from the holes on both of these. I'm just going to stitch these in on the bottom and we're ready to prime. So I have this with just the 2 9-degree magnet clamps kind of checked out that were square. Really doesn't matter much, but I just want to do a good job. And then we can see we're pretty well lined up with the top there. So when the top sits on, it'll be good, and we'll just reach in through this hole and weld that up. Grind hurts. And we have us some bolsters. This is as far as I'm going to weld them up in order to prime them with our zinc heavy primer. I'm going to take them back out because it's a nice day and I'm just telling myself I'm doing everything I can for these. I'm going to take the sandblaster and just hit all the welds real quick, and that way we'll be as clean as we could possibly be in order to prime this. We had a little bit of fumes and smoke and whatnot, so I think the sandblaster is our easiest way to clean this up. And everything now is as clean as it can be. So we got our parts laid out in here to prime. I'm only going to worry about the insides. I'm not going to do anything on the outside of the bolsters or the outside of the hangers, because when we weld these to the trailer, which is going to be a whole lot of welding in this area, we're going to mess that paint all up anyway. Then we'd be kind of like sanding out the difference. I'm not going to worry about it. I just really want to get a good coating on the inside of these guys, because once the top's on, you still have the holes, but it'll be limited. I think this is our best chance of survival. I appreciate you guys sticking around for this one. I know it's a little bit longer of a video. We've been here, there, everywhere. Been a little bit hard to kind of capture the whole process here, but things are moving along. I'm really happy about it. This is a ton of work. I don't know if this video really shows how many more hours than you can film or just behind the scenes of a video like this, but I think this trailer is going to turn out really nice when it's done. I'm excited for it. I've always wanted a lowboy to be proud of, and when you can't afford it, you got to build it. So glad you guys are along for the ride. I'm Sam with Scrappy Industries. Thanks for watching. Been a day, huh? It has been a day.
Swing. Ata.